starting our last unit. How's that for a thought? Okay. Okay, starting 8.1. So 8, if you bothered to look at the title page as you flipped across, it was applications of integration. So for our third unit in a row, we are integrating. Okay, a lot of this, I think we finished this unit by talking about volume, which is a big thing that is one of our big applications with integrals, is volume. So we'll talk about area under a curve, we'll talk about volume, and just try to remember what else I saw in there, but a few other miscellaneous. Today, we're going to focus on two thoughts that kind of go together, and that is average value and mean value theorem. Okay, so the area of a region under a curve is greater than the area of an inscribed rectangle and less than the area of a circumscribed rectangle. The mean value theorem for integrals states that somewhere between the inscribed and circumscribed rectangles, there's a rectangle whose area is precisely equal to the area of the region under the curve. Okay? Now, as you look at this, I'll try and explain it using the diagram there. If f is continuous on the closed interval from a to b, and that is, I guess I should tell you where a and b are, shouldn't I? There's a at the origin, there's b. Then there exists some number c, and that is represented by this dotted line, in the closed interval a to b such that the integral from a to b of f of x dx is equal to f, the function evaluated at c, times b minus a. Now, the idea, if we go back to the beginning where it talks about an inscribed rectangle versus a circumscribed rectangle, the idea there is, okay, so this curvy thing is my curve, right? And an inscribed rectangle would be going here at the lowest point and having this bottom rectangle down there. Okay, that obviously is going to be an estimate that is going to be below the actual value. Okay, circumscribed would be using this highest point and having your rectangle up there. So now if we have that rectangle up there, that rectangle is a much bigger rectangle, yes? Okay, so the mean value theorem states that somewhere in between, so somewhere in between that lowest point and that highest point, there is some value c whose area is precisely equal to the area of the region under the curve. So like right there, we picked the smallest possible value and the biggest possible value. Somewhere in the middle, which they're saying it's right here on this curve, somewhere in that middle, if, excuse me, you look at that value right there, the area is precisely equal to the area of the region under the curve. Okay? Now, we've talked about existence theorems along the way. Mean value theorem is an existence theorem. Mean value theorem doesn't tell us how to find c, it just guarantees that there is some number there that exists in that interval from a to b. Okay? And so we're going to talk a little bit about mean value theorem. With this, let's see, what do I want to label here? What's an integral represent? Antiderivative. What is it in relation to, like derivative, we talk slope. Integral, we talk area under the curve, right? Okay, so the idea here that this integral is equal to the area, probably should have just written area, but that's the area under the curve. When we talk about f of c over here, and b minus a, your f of, or, well, I'll start with b minus a. B minus a is going to be the width of the interval, and f of c is the height. Okay? Sounds like we get to be part of films class today, don't we?
Miss Holland likes to
I say, is Miss Minnick here?
No.
No, she's gone again. Okay, so that's, I've noticed it is louder when Mrs. Huntley's in there, so, okay. Is it a good movie they're watching?
Sounds fun.
It's a movie. It's better than calculus, right? Is that what we're saying? Okay. Okay, so the idea, area under the curve, right, is equal to, when we just talked about general rectangle there, right, the height times the width. F of c, we've done that, right? That's the height of the function, right? F of c, wherever that might be, b minus a being our width. So just trying to help you guys understand that connection there. Let's see. And I guess the one other thing I have labeled in my notes is that if this point is C, then the F of C value is right there. So that rectangle there that is what? On my picture, mostly green and a little blue, that's going to be equal to the area under the curve. Okay? Which, if you look, the blue and yellow are equivalent there, it looks like, or just about. So, okay. We'll talk more about that as we go. But we're also going to talk about average value function. Okay? The value of f of c, given in the mean value theorem for integrals, is called the average value of f on the interval. When you see a word problem in calculus, and they throw the word average in there, you want to watch for that word average, and you kind of want to perk up and think, oh, average value. Okay? If f is integrable, did I say that right? Sure, we're going with it. I would say integratable because that's what it's coming to my brain. But on the closed interval, a to b, then the average, the mean value of f on the interval is this right here. When you're asked to find the average value on an interval, basically you're doing the integral from a to b, but out front you need to throw in a 1 over b minus a. And I will say this is how I've seen it expressed before, but it's also shown as this down here where putting the integral over the b minus a, realizing that is equivalent there. Okay, so we'll talk about average value, 1 over b minus a times the integral. Could also be written as the integral divided by b minus a. And if you think about it right there, that is writing the area divided by the width is what that is writing. And notice that's going to find, if you're doing area divided by width, that's going to find the average height, which is also, I'm not going to be able to write in there, it's too close, but that is also f of c there. Okay? And we're going to put that all together here. Okay. We have a few examples in notes. I don't feel like we have a ton of examples in notes, though. I think you get a lot to do, a lot of your examples in the homework. So, given f of x equals 3x squared minus 2x, first thing we're going to practice doing is finding the average value of f on the interval 1 to 4. So, what keyword do we have to focus on? I saw the word average. And I'm just saying that that will apply within word problems. Okay, so you see that word average, realize this might be what they're asking for. Now, in order to do the average value, basically you're doing the integral from 1 to 4, but what do we have to put out front? It's 1 over b minus a. Okay, so in fact, if I write it first, it's 1 over b minus a times the integral from a to b of f of x dx is what we're doing. So in our case, we're going to go 1 over 4 minus 1, realizing b minus a, larger minus smaller, times the integral from 1 to 4 of 3x squared minus 2x dx. Well, what do we know? 1 over 4 minus 1 becomes 1 over 3. I don't feel like we've done a lot of integrating by hand in a while, but guess what? We're going to integrate by hand. What's the integral of 3x squared? Okay. X cubed minus the integral of 2x. x squared, and then evaluated from 1 to 4. You can do this how you want. I personally would just keep the 1/3 out front. And we remember how to do this by hand, yes. We're going to evaluate upper limit and then minus lower limit. So 4 to the 3rd minus 4 to the 2nd, and then minus, and then it's 1 to the 3rd minus 1 to the 2nd. Obviously, you guys shortcut pieces and stuff at times, which is fine. What do you have? 1/3 is staying 1/3. 4 to the 3rd, 64, minus 4 to the 2nd, 16, minus 0. 1 minus 1 is 0. So 64 minus 16 is 48, I think. I'm agreeing with my answer key. And then a third, what is a third of 48? 16. Okay, so that is finding your average value. Basically, you're finding the integral, right? And then multiply it by 1 over b minus a. Watch in homework when they ask you to find the average value. There are some of those pieces where they went ahead and gave you the value of the integral. Okay, so just kind of watch what they give you. I don't know. They kind of set some of the homework problems up kind of weird, I thought. But okay, part B. Find the value or values of C guaranteed by the mean value theorem for integrals. Now, the idea, and which way do I want to set this up? If we set it up, okay, I think I'm going to go with the idea that the area under, I'm trying to put it in words for you because that was helping me when I was doing this. Area under the curve is going to be equal to the, what do I want to say, the function value, which is the height, times the width of the interval. Okay? So I'm going to say function value times the width of the interval. Realizing function value is also another way of saying that is the height, right? Probably not a spot. That, okay, that is not readable. Why did I write over that? Is that as bad as it is to me and I'm up close? Yeah. Wow. It said height. That was a bad idea to put that there. So just trying to remind you, function value is the height. I will write it in there instead. Is that better? Might be small, but at least. Okay, it seemed like a good idea. Green is bright. It shows up. Showed up, but that doesn't make it readable. So, what represents area of the curve? Area under the curve. The what? Yeah, the antiderivative, the integral. So the area under the curve is going to be the integral from, what's our interval here? 1 to 4 of 3x squared minus 2x dx. Okay? And that's going to be equal to the function value. Okay? Which, what we're going to call that for right now, because we're trying to, function value is in f of x, but we're trying to find a specific value of c. So we're going to call it f of c, okay, times the width of the interval. How do I do the width of the interval? Well, that is your B minus A. Excuse me. Now, we already have most of this information. Can you tell me the value of the integral from 1 to 4 of 3x squared minus 2x dx? What would that have been? The 48, right? Not the 16, because the 16 was when we did average value, and that's a third of it. So this side is 48. F of C, I'll leave it F of C for our step here. 4 minus 1 is 3, yes? So do your smart math, and what do we know about F of C? Okay, F of C is 16. Now, we need to find C, right? Which, I guess pause for a moment. What's the shortcut here? F of C is equal to the average value, yes? Okay. What is my function? My function is 3x squared minus 2x, right? What is that? What is that if I put C into it? I think I'm gonna go over here because I didn't give myself all my room down there. So F of C, instead of 3x squared minus 2x, I'm gonna say 3c squared minus 2c equals 16. How do I solve this? Subtract the 16. And we need to factor. Do you guys have a way you want to factor?
6 and 8.
Okay, I see what you're. So product of AC? Okay. Okay, so move to learn a new factoring technique? Or would you rather not?
Sure do.
If you latch onto it, I think you'll like it. So here's the deal. I teach product of AC, yes? You guys all had Mrs. Rogers at some point or another, although some of you only had her for geometry, I guess. But Mrs. Rogers teaches the X method, I think. I don't remember did she just call it the X method? I don't know. You had her for Algebra 1, didn't you?
I don't remember.
You don't remember? Okay. So, I don't know. I teach product of AC. She teaches X method. Well, she's using these new notes this year. And these new notes had something, they called it the slip and slide method. Okay, just go with it, right? But I thought it was kind of cool. Okay? So, I'm going to go up here so I have a little bit of, I've only done it once, and the only time I've done it was working a problem in this homework. Okay? So, we're going to slip. I think this is what it is. I don't remember the exact vocabulary. But we're going to take the 3, and we're going to multiply it over there. So if I multiply that over there, c squared minus 2c minus 3 times 16 is 48, yes? Which that's what, for those of you that were starting product of AC, that's what it was, right? Okay, can you factor this? Factor c squared minus 2c minus 48. So c and c, what do we need? Minus 8 plus 6? Okay, so I slipped the 3 over here, but here's the deal. I multiplied by that 3. Now I've got to divide the 3 back out. So we're going to divide both of those pieces by 3. I don't know exactly how to explain this, I guess. And when we divide both of those pieces by 3, well, this one is c minus 8 thirds, which I'll have to deal with in a moment. This one is c plus 2. And this 3 right here, I mean, officially, if you multiply this factor by 3, it's going to put the 3 out here. But basically, you're moving the 3 back out front. need to work on my explanation of that if I want to use that in the future. I haven't thought about all the explanation. Now, did anyone get as far as finishing product of AC? This is the same answer you'd get. I don't know. I mean, it's going to take a couple of times to practice if you like it, right?
Does it always work?
Yeah, it should. Okay. I don't know. Not my intention to show it, but Mrs. Rogers, she kind of showed it to me like about a week ago. Kind of like, this is different. I was like, that is different. And then she came to me just a day or two ago. She's like, oh my gosh, I love how this worked. Like after she taught it, she was like, I really like it. So, I don't know. Might be a new and future thing to use, but it's a thought. Multiply the A value over there, factor it, and then the key is, since I multiplied that A value over there, I have to divide it back out now. So I divided it out. That one simplifies. This one, the 3 is going to go back out front. So, I don't know. I mean, it should match what I have in my notes, right? Yeah. So, this is 3c minus 8 times c plus 2. If you don't like it, go back to the other, right? Or if you can't, when you can't remember it later, go back to the other. Okay, solve. What do we get here? C can equal 8/3 and C can equal -2. Now, it is possible to have more than one value of C. However, you do need to check them in terms of, are they in the interval we're talking? What's my interval? 1 to 4. Are they both in the interval 1 to 4? 2 does not actually work because it is not in the interval. And so my only answer here is going to be the 8/3. Okay, so side note there, must be in interval. Okay? Questions? I know Jacob said he kind of thought he might like it. I don't know. Any other thoughts? I'm just curious. Or you'd have to, huh?
I like it.
You like it?
It's kind of cool.
I feel like it's easier to remember than the product.
Yeah.
I feel like it's less intense. Like, I feel like it's just easy. Once you know the routine, I feel like it'll just go a little quicker and smoother.
I think it's simpler once you understand
Yeah.
it.
Yeah, I think that's the thing right now is trying to remember,
Yeah.
brand new, trying to remember it. We just did one random example, so you'll have a little bit of factor in your homework, so you can try it if you want. So, okay, moving on. In 2000, the world's population was 6.1 billion and the relative rate of growth was 1.4% per year. This can be modeled by the function n of t equals 6.1 e to the 14,000s t, where n is people in billions and t is the number of years since 2000. Assuming this model remains true until 2050, find the average population of the world between the years of 2010 and 2020. What are the units? Okay, thoughts? Not the thoughts I was looking for.
Average.
Okay. Peyton's keying in on this word here. It wants us to find the average population. So what's that telling me to use? 1 over b minus a times the integral from a to b of f of x dx, yes? All because I saw the word average. Well, not only because I saw the word average, but okay, thoughts? What do we know? What are A and B going to be? 20 and 10? 10 and 20? Because notice it was years since 2000. So if we're talking 2010 and 2020, A is going to be 10 years and B is going to be 20 years since the year 2000. And then our function is provided, yes? So set it up. 1 over 20 minus 10 times the integral from 10 to 20 of 6.1 e to the 1400s t dt. What'd you notice up in the corner of this problem? Calculator. Good news is we don't have to integrate this by hand. Technically, we could integrate it by hand. Well, we'd still have to have a calculator usage because of the decimals. So. Well, remember how to do the integral on the calculator? Math 9. There's other shortcuts too, but that's the one I know. What are we getting?
7.15315.
Yeah, I have written down 7.53158. I think I went past that. So, or in other words, approximately 7.532. Okay. So find the average population of the world between the years 2010 and 2020, and what are the units? So in other words, explain this. Put this answer in words. What would you say about this answer in words?
That's how many billion people.
Okay. That is billion people, yes. The average population was not 7.5 people. Okay. So 7.5 billion people, when? Between the years 2010 through 2020, right? So I have written in my notes, average population of the world is approximately 7.532 billion people between 2010 and 2020. Okay. By the way, did we all get the calculator to cooperate with us? I hope, if you tried it. So, put an explanation of some sort. With free response, that's a habit you need to be in, is putting a little bit of explanation there. So, average population is approximately 7.532, keyword to get on there, billion people, oops, between 2010 and 2020. So, again, key thing is you have to get the billion on there, but some other information is helpful. Okay. 3. No, it says this is a calculator problem, but
I think we should do this calculator.
well, but here's the deal. Did I not read the full directions? Suppose C of T represents the daily cost for air conditioning your house in dollars per day where t is the time in days and t equals 0 corresponds to July 1st, 2017. Explain what the following expressions represent in real-world terms, including the units. Yeah, there's no math to do here because we don't have a function. We don't have a C of t. So, okay, we're explaining what they mean. And you know, I mean, the big thing to notice here is the difference between a and b, right? So thoughts on a? The integral from 0 to 90 of c of t dt. What would your thoughts be? Go for it.
The total cost of air conditioning in the 90-day period
Okay. And what is that 90-day period?
from July 1st to 90 days after that.
Which? July, August, September?
Yeah, but isn't that like 31 days and 30 days?
Don't get tired.
It's
So
That's why they.
And that's why exactly. Now, and I will say when I went to look in my notes. Oh, okay. In the notes, it's written for July to September. Like when I looked in the key for the notes there, it said July to September. So you need some variation, you know, some explanation there. I would indicate it for 90 days. It would be probably good to throw an explanation in that when does that 90 days start? You know, so maybe you don't go as far as figuring up that 90th day, which I don't blame you there, but either, you know, generalizing July to September or starting July 1st for a duration of 90 days, okay? But yeah, so the idea is we're accumulating the cost. This is your total cost, okay? So total cost to cool your home for July to September. Whoops.
Days after July 1st. September 29th.
And in all honesty, as I think about that, I just wrote total cost to cool your home from, you know, for July to September. In all honesty, it probably would be better for me to say starting July 1st for a period of 90 days. That's kind of the afterthought after I just wrote that out. But there's a variation, however you want to explain it, you know. Key things here, total cost, and indicating what is that time frame. It's July to September, it's 90 days starting July 1, some kind of indication there. Now, what about B? Okay. Okay. So well, we don't want to throw the word total in there.
The average cost.
Yeah, it's going to be the average cost over that same time period, right? Let's see, average cost to cool your house. And this is for the 90 days from July 1st. And we didn't talk about it last time, and we probably should have. What's the units going to be? How would you express average cost? Dollars per day, right? Because our time was specifically where there's dollars. Well, and actually it even mentions it right here, right? Dollars per day. So. Okay, so average cost to cool your house in dollars per day for 90 days starting on July 1, 2017. Okay. Some kind of explanation. Those explanations are real. That is, when we really sit down with pre-response, leading up to a test, that pre-response is going to be important. Okay.
Finish.
I know, I'm trying. Well, I was just looking ahead. 8.2 is 5 pages. We haven't done that for a while, I don't feel like they've been that long, but. Okay. Supersonic Man. On October 14th, Charles Yeager flew his X-1 rocket plane at an altitude of 12.8 kilometers. He was clocked at 299.5 meters per second, which is about 669.962 miles per hour. At different altitudes, sound travels at different speeds. We can model this variation for speed of sound with a piecewise function given below. And the data link is even there for whatever reason. Okay, A. A says to integrate the function s of t over the interval 0 to 80 for the first 5 subintervals.
We need to make sure that's right.
We need to go to the link and check it out. Okay. A. Integrate the function s of t over the interval 0 to 80 for the first 5 subintervals. So what's the first interval? First interval is 0 to 11.5, right? And what's our function there? Okay. We're going to need values here. So what do we need to do? Put it in the calculator. Unless you want to go ahead and write these all down, and then you can put them all in the calculator. I mean, here's the deal. We've got 4 more to go here, don't we?
That's a lot of work.
It is. It's a big problem. Notice there's half a page blank in your notes for it, though, too. So. Is this a messy decimal?
I got a straight answer.
It's a whole number.
Okay, it is. That's what I was trying to figure out. I'm like, I was just starting to go back to my calculator. I'm like, did I really round this to a whole number? But no, it's a straight whole number. Okay. That's what I have written down. I just started thinking, man, why did I round to a whole number? I shouldn't have rounded to a whole number, but it's because it is a whole number. Okay. Next one. Interval of 11.5 to 22 of 295. That one wouldn't be hard to do by hand. What do you get? I'm assuming it comes out exactly. I said I scared myself that maybe I wrote them down. I rounded them. Got 3 more to go, yes? I went ahead and wrote all 3 integrals out, just waiting for answers when you guys get there.
$9,210.
Now, keep in mind, these are all S of t, right? Altogether, those are S of t. Now, you guys might have room still below. I'm going to have to go beside because I don't have room. So part A was integrate the function over the interval for the 5 subintervals. We did that. B is apply the mean value theorem for integrals to find the average speed of sound. Notice, what keyword did you hear in there? Average. So how are we going to do average? What?
Or 1 over 50 minus 11.5.
No.
80 minus 0.
The integral is officially 0 to 80, yes. So 1 over 80 minus 0 times the integral from 0 to 80 of S of t dt. Now, that fraction out front is easy enough. 1 over 80 times, what about the integral from 0 to 80?
Add
It's going to be those 5 values we just found added up. Yes? Because remember, an integral can be broken into different subpieces, and that's what was done here. So this is going to be 1 over 80 times 3,657 plus 3,097.5 plus 2,987.5 plus 5,688 plus 9,210. Is that and it's an exact number again, isn't it? Yeah. I have written down that it's going to be 1/80th time 24640, and that comes out to be 308. 308 what? Right, because we're talking speed here. Meters per second. I personally stopped there on that part B. I'm not sure why, because I don't see it in the problem anywhere. But on the answer key, when I checked mine against the answer key, she has it in miles per hour also. I'm not sure why.
Probably-
Other than because we live in America.
Or because the top also mentioned miles per hour.
Does it? I didn't see it.
It's 669.962 miles per hour.
But it never asks for it.
Which is about true. I guess I missed that they did mention what it is about. But yeah, so anyways, I wrote down that it was 688.976 miles per hour if you're curious. But in my opinion, it never asked for that, did it? So it just said apply it to find the average speed of sound.
You know,
So
it's really weird that meters per second is M over S and miles per hour is not M over H.
it can be M over H.
It's
It's
not
just
how
more
we
traditionally
write
written as MPH, yeah. Okay, C. Draw the average value, S of C, on the graph below. What is our average value? Average value is 308, yes? So where is 308? Right below 310? So that right there, that green line is going to represent my 308 meters per second. Which regardless of finding the miles per hour, the graph is done in meters per second. So what do I want to graph? Meters per second. Okay. Now, does that average value make sense? Equal portions above and below, maybe? Give or take? Okay. So here's what I'm going to say. I don't have lesson plans done for next week. In my brain, everything's been taking 2 days. So my brain, I think I had planned this probably as 2 days, but it didn't take 2 days. Here's what I can't guarantee. I can't guarantee I'm going to have the next set of notes done for Monday. So, I'm going to say homework due Tuesday. Okay? Now, with that in mind,